All right, hey guys. I'm Max Sobell. This is Corey Benninger. We're going to do Intro to Near Field Communication, NFC Mobile Security. So we've got the jerseys. We're doing the NFC Championship. I've got the good guys. He's got the Giants.
Team that fumbles less than your team.
So welcome.
Okay, so an overview of what we're going to talk about here today. We've structured this as an intro in case you've never heard of NFC before. So we'll go into its common uses, a couple examples of that. Then we'll talk about some of the hardware basics behind it, including the waveforms, some of the popular tags you'll see in access control. We'll give an overview of the NDEF file format that's mainly used for these tags and devices. Then we'll get into the good stuff of the actual attacks on the devices that we see right now. Talk about NFC and privacy, and then wrap up with some information about mobile wallets so far. A little background on us in the Intrepidus group. You've probably seen our punching bag and crazy glue stuff down the way, so that's us. If you can't tell what we do from that, it's mobile security, applications, devices, testing, and so forth. Android, iOS, WebOS, Windows Phone 7, whatever. Today we're going to basically be focusing on Android and iOS, Android and BlackBerry, since those are the two where we've seen NFC here in the States.
So a little background, what is NFC? It's an RFID technology. The frequency we'll be covering is 13.56 megahertz. The most basic NFC stuff is covered by the ISO spec 14443. It has 4 parts. First is the physical characteristics of the antennas. Then you have the radio magic, a little bit of initialization and anti-collision, and then finally the transmission protocol, which I think this is a good time to point out is not encrypted. It's up to the applications to encrypt that transport layer. The players in any NFC transaction are a powered device, and usually that's going to be your phone. Then there's the unpowered device, which is a tag. And they look like this. So you can see there, they're pretty small.
Yeah, that's a New York Metro card, so you can get a sense. They're really thin, they're pretty tiny. They don't need a lot of space at all, which makes them pretty nice to use for this.
One of the questions we get a lot is NFC RFID? Well, yes, it is. It's under the RFID umbrella. RFID covers several different frequencies. There's 125 kilohertz, which I think Brad will talk about. There's 13.56 megahertz, and then there's the 900 megahertz. So we're just focusing on this middle band here. It's a type of RFID. It's short range, so if you can see the chart here, there's the inductive section and radiative. So this is an inductive technology. It's near field. And these tags have enough computational power to perform basic crypto and access control.
So as Max kind of just mentioned there, these are a little bit more advanced than the HID cards. Brad's talk tomorrow morning will be focusing on that technology. That's not what we're going to be talking about here today with NFC. We're going to be talking about things like Google Places. So this is an idea kind of replacing QR codes with NFC tags. You go to a restaurant, want some information about it, touch your phone to their Google Places page. It should pop up on your phone and give you more information.
We'll also have some fun with parking meters. This is an NFC implementation we've seen where you scan the NFC tag with your phone, it pops up their mobile app, and then you navigate that to pay for your parking space. So it's pretty recent and pretty cool.
And then a number of transit systems actually use NFC-enabled tags for communication. So Charlie Card, which there was a great presentation on that a few years ago about breaking those. Orchid Cards up in Seattle, Oyster Cards overseas are some examples of those.
We'll do the hardware magic section. So some of the hardware basics behind NFC, we just touched on them, but it's inductive coupling. So that's why the tag looks like a coil. And it's not your typical antenna. It's a near field technology, which means that the range is severely limited. So the stated range, and we'll emphasize stated, is 4 to 10 centimeters. So we know there's some research being done on expanding that range, but we'll leave the fireworks to other people. Inductive, the wavelength is about 20 meters for the 13.56 megahertz wave. So that's much longer than the antenna diameter, which makes it near field. The important thing to take away from this is that there's one device providing the power, typically, and that'll usually be your phone. So you have the energy going one way, and the data is coming both ways. Here you can see some NFC antennas. So on the left is the Samsung Nexus S. You can see the antenna is kind of a standalone thing there. It's kind of just pushed into the back of the case, and then the leads take you to the actual chip. In the Galaxy Nexus, the antenna is built into the battery, which is kind of an interesting way to do it. And then across those 4 to 10 centimeters, it's radio wave communication. It uses amplitude shift keying, and it looks different, reader to tag and tag to reader. So the reader to tag, you can see on this top left picture, 100% amplitude shift keying. That gray there is the carrier wave at 13.56, and then it's coming all the way back down to 0, 100% amplitude shift keying. And then the tag to reader looks different. It's not a sawtooth wave, but you can see the little saw teeth there. It's just 10% amplitude shift keying of that carrier wave. So we can see that here. So, oh, I'm sorry, the baud rates on NFC. You can see it's not very fast. We don't even see tags very often that use 424 or 848. So it's typically the slower 106 or 212. So in applications where a file is going to be transferred using NFC, we'll typically see the NFC used to pair Bluetooth or to connect the device to a Wi-Fi hotspot and then transfer file that way. Because it's pretty slow. You'd have to actually hold the devices together the whole time. Not a great way to transfer files. We were curious about the spec. We took out our oscilloscope, just sniffed a reader waking up a tag. So this is 52. 52. You can see the carrier wave there in the like lightish green. 13.56 going really fast, much faster than the 100% amplitude shift keying. And you can see it's broken down into 3 symbols, the X, Y, and Z. And then at the end there, you can see a couple Ys. So this is 52, and then the Ys are extra. And what that is unmodulated energy to keep power to the tag. And then, because the tag doesn't have power of its own, and it has to modulate that energy to respond to the reader's request. So you can see that here. On the left here is actually, it looks a little bit different because we generated it using a USRP. And then on the right is the tag at 10% amplitude shift keying. So that's that little thing. It looks like a saw again. So this is like your basic, just wake up and then anti-collision. Each tag has a unique identifier on it called the UID. It's like a serial number for the card. So it's locked on these physical tags. But Corey picked up a $80 Chinese manufactured card where you can actually rewrite this UID. So using the UID as a safeguard is decent, but just keep in mind that it can be emulated, or using this knockoff card, someone can take your UID.
Yeah, the price for these tags are usually between $1 and $2 or so. So $80 per tag is a considerable hike.
Just to emphasize again, the tags are more than just memory sectors. So the reader will send a request to read and write data from the tag. It'll actually request, a data sector, and the tag will return that. And then we'll get into, next slide, tags can have access controls. So you can request access to a sector and be denied that based on access conditions in the tag. MyFair is a big tag manufacturer. So most of the tags we've seen are, well, MyFair tags. And here's a breakdown of some of their most common types. So the ultralights are what we've been showing. They don't have much space on them. They can be locked for writing, but they have no access control. So you can read anything on them. So they haven't been broken. But the classics, that's that Charlie card that we showed earlier. There was a great talk on that, like a couple years back. Those were torn apart in 2008. So the access control on those is basically non-existent. The DES fires, up until, a couple months ago, hadn't been broken, and they had great access control. Now clearly they don't. So the last remaining, well, one of the last remaining tags with good access control is the DesFire EV1. So a couple of those tags that we showed in the transit cards are actually using DesFire EV1. So for now, the data is safe on those tags. So a little bit about the data on the actual tag. It's in a format called NDEF, which is the NFC Data Exchange format. It's a pretty basic format. The specs come from the NFC forum, which is comprised of some of the major players in NFC. And they got together and produced the specification NDEF. So there can be several NDEF messages within one NDEF record. Some of the common ones are text, vCard. URI is kind of interesting because you can, just to save space, map these hex 23 prefixes to SMS, TEL, HTTP. We'll show that on the next slide. And then the Smart Poster actually combines the text and the URIs. So that definitely looked like fun. So here are some URI identifier codes. You can see it's hex 0 through hex 23. Just to point out a couple, 05 is TEL. You can see, yeah, you can read it. You can see FTP, TCP, OBEX. Like, they're interesting ones, definitely. But this is just to save space. You could always just write this straight on the tag if you had enough space.
So let's see if we can show you a little example here. This is just mirroring the screen on the Nexus S that I have up here. So this is a really popular good tag reader application. I'll show you the data on here. So I push this to the back of the Nexus S. New tag is detected. And then we can see that NDEF message format. This one's formatted. Oops, it's a little slow updating. Let's see if I go back one or not. I want to see if that'll play. Yeah. The live demo is fun. Okay, so for those of you that are far away, you won't be able to see my screen at all. But basically, you can kind of see that this raw data in hexadecimal form is written to the screen on there. And Max is going to break down what some of that data means.
So yeah, this is, like Corey said, if you just read all the data sectors one after the other, you'd get these bytes. It starts with D1, and then you have length of payload length. Then you have the actual payload length. There's some interesting fields. You have the URI, which is hex 55. We pointed that out earlier, and then 05. So once you have the URI, then you're encoding TEL, and then the actual payload is the 2B through the 37, which I believe is +1 555 1 2 3 4 5 6 7, and then you have your terminal value character is FE. So that'll end the NDEF record. So some of you may have noticed there's lots of lengths and reserved for future use. So it's an interesting format to look at, and definitely some of those values you change can get you a crash in the Android built-in tags application. So it's NDEF parsing is commonly built into the operating system. It's kind of the most basic NFC format. So we've looked at these a little bit. All right.
Let's see when this comes back up if we can relaunch it. Okay, so now you kind of have the basics of NFC and what it does. We started looking into how this has been broken in the past, because we kind of got NFC a little bit late here in the States. It was popular overseas. So there was already some research that had been done on this, and Colin Mulliner has a great website where he really talks about some of the research he's done. Started off with the Nokia devices, and he's updated it with some of the Android things, but he's got some great code working with Python and the Nokia devices. There's also been some research done on the Nokia devices and trying to set it up so it can transfer arbitrary files over Bluetooth. And so our devices aren't quite that advanced yet. You kind of have to go through another application to get that to work, so it doesn't really apply to what we're going to talk about here. And then recently down at KiwiCon, Nick, I'm going to kill your last name, had a great presentation of doing a mobile point of sales terminal with his phone and hooking that up with RFidiot through it. So there's definitely some cool stuff going on in this field. But one of the first things that we decided we were going to look at here was Google Places implementation, because that was one of the first things they were working on rolling out here. Putting these tags at these different locations, we're wondering what sort of access control restrictions might be in place, are the read-only tags being used, if there's any sort of physical protection around them, stopping somebody from changing the information on those tags and doing something different with them. So if you've gone on YouTube before, you may have seen things about building an RFID zapper out of a disposable camera, sending really high voltage to a tag and frying it that way. I decided I didn't want to try to electrocute myself too much, so instead of going for that route, we thought about what were some of the low-level attacks that could be done. And this was something that Colin also touched on as well, is if you actually have one of these tags and one of these maybe RFID ID shields, these are fairly popular for blocking your credit cards in your wallet. You can put in a little shield, and I'm sure there'll be some interesting stuff coming up about those. But what if we cut a little piece of that, use that to block the tag underneath us, and then put our own tag on top of the Places poster. So now when you go up, you try to read that data with your phone. Instead of reading the actual data, you're going to now read this counterfeit tag on top of it. So that's one sort of physical attack that you can take, and hopefully somebody doesn't notice you've altered and put your own tag on top. But what if you just try to actually change the data on the tag itself? So when we were finally traveling around a little bit for work, hit a town where they actually have Google Places NFC deployed on there, and we read one of these tags with that application I was trying to show you earlier on the phone. And the data that came back to it, it's probably really hard to see from pretty far back there, but on the left-hand side, there's one of these columns, one of these rows that says is writable, and it's yes. So that means anybody else with a Nexus S can walk right up to that tag and rewrite the data on it. These were ultralight tags, so there's no access control. There could have been a challenge response, sort of encryption to make sure you had the proper key before changing the data. Simply could have been written once and then locked so nobody else can change it. But that hadn't been set. So if you're putting out public tags, it's probably something you're going to want to do with them. Countermeasures, though, for sort of the physical destruction, the zapping, the DOS attacks, that's a really hard problem to deal with, at least from what we've heard and talked about so far. Really be curious if somebody has good suggestions and ideas about that. Love to talk to you at the booth afterwards about it. For the counterfeit tags, though, putting your own tag on top, there are some specifications that could help you mitigate that. One is there's an NFC signature record type definition. So that's actually one of the specifications from the NFC forum. So you could sign each of your NDEF records in your tag. And there gets to be some interesting attacks with kind of these Franken tags and which data is signed and what data isn't signed and how that's checked. You also have to roll your own PKI for actually checking and validating those signatures. So it's a bit of a pain, and I don't think we've seen anybody actually implement or use that yet. One other suggestion was, well, what if you use these UIDs, these serial numbers, as kind of a whitelist? I'm only going to read or respond to tags that I know have my serial number or a serial number I trust. So then it just gets in the pain in kind of managing those tags.
So the obvious next step here is phishing. So we wanted to cover how some of these operating systems parse long URLs. So Colin did it for us with the Nokia. You can see he's entering in, maybe you can see, carriage returns. So he's mimicking the layout of the Nokia phone once you scan an NFC tag and tricking kind of a hurried user into clicking that tag that's not actually going where they think it's going. For BlackBerry, the first screen there, it looks like you're going to RBC Royal Bank. But once you click View, which you have to do to open that link, you actually see the whole URL. Clearly, you're not going to RBC Royal Bank. On Android Gingerbread, looks like you're going to RBC Royal Bank again until you turn the screen, which isn't something you have to do to click on that. So, ice cream sandwich.
All right, let me see if I can launch the demo app again to get this going. Kind of updated this for ICS late last night. It's not officially supported on this build, so it's been a little bit cranky. Get in a picture. All right, sweet. Can we move that to, yeah. All right, yeah, just the right-hand side. All right, so let's see how well this holds up here. So now if I take a tag with a URL on it, put it to the back of the phone, automatically just launches to that location. No user interaction required. Hopefully you see the URL bar as it loads up, but if I had a faster internet connection, it'd probably load up pretty quickly on there. And it might be hard to know if this was an actual phishing site or not where it was taking you to. They've really been moving towards this idea of zero-click integration. That's also kind of the effect with their beam-to-beam applications. They're just sending data from one device to the next, and for the most part, usually automatically accept it on the next beam device. Actually, can you go ahead and put that back up? So there's a couple of URL types besides just the HTTP tags, the URLs, that are automatically handled by Ice Cream Sandwich. Another one of those now is vCards, contacts. So I just created a vCard. I could have had this, say, on my business card or anything else like that. Somebody goes and scans your tag, loads up. You can't tell what data is actually on here until you scan it and put it into your phone. So we just made one for your mom. At this point, it's actually saved on my contact list. I didn't have to tell it to save or anything else like that. It just shows up now here anytime I go to my people's tag. It just added that contact on there. So it's kind of funny, actually, if you scan it again and get there, now when you go to your list of contacts, you have two moms. Pretty hot. All right. So the beam technology, when you do device-to-device with Ice Cream Sandwich, is actually just passing types of these NDEF messages from one device to the next device. So in a lot of cases, you could actually encode that message to a tag. Instead of needing to go device to device, you can do tag to device. So that may play out kind of interesting here as more and more of these services come out, more and more uses. All right, let's see if I can close that down now. And that. All right. So that's kind of the zero-click. One other way that we saw this implemented was if you're actually developing your own application that's going to make use of NFC. One of the ways that we saw this was with a Google Maps application. If you had a special Google Maps tag, it'll just automatically go ahead and launch Google Maps on your phone. So there's a whole breakdown structure of when an application will handle it. If the application's in the forefront, it'll grab the NFC antenna first. If not, there's a whole structure where it'll go through and figure out which application wants to send that NFC interaction to. And the way you would program this in your Android application is actually with an intent filter. So if any of you have written Android applications or gone through decompiling them, came to Matt's talk earlier, he kind of mentioned the Android manifest XML file is a really important key file for any Android application. This will contain any of the permissions the application is going to use, information about any services, broadcast receivers, so forth. It's all stored here in this manifest file. One of the things you'll see is intent filters. So NFC intents actually have their own intent filters that can be set up. And if you look at the Google Maps application and through their Android manifest.xml, you'll actually see tons of these for all the Maps top-level domains that are set up in order to grab these tags and load it into the Maps application. So we were thinking about this. What's preventing any other application from actually asking for these same intents? You don't need any special permissions to have intent filters. You can just build them right into your applications. So that's one of the things that we played around with here. And hopefully, let's see here if we get that back on screen. Can you,
Yeah.
should I get that? So I created, I have a little tag here in my hand. If I put it to the back of the Nexus, it's going to load up into Maps. And people were telling us about a great bar around town that we needed to check out. So I'm going to say this very slowly. It's called The Big Hunt. So we hear that's a good place. So tag just automatically goes ahead, loads that in Maps and in Google Places. So we figured every demonstration needed an Angry Birds application. We'd go ahead and write one for this. Loading issues again. All right, here we go. So I could have put this in the market, but I'm just going to install it locally so that everything goes a little bit quicker. And since we're from New York, we have to pick on New Jersey. So we have our Angry Birds New Jersey application. Now, watch as I install this here. I'm just going to click install. I'm not going to be prompted about permissions because I'm not going to ask for any special permissions at this case. I'm just going to tell it to install, take a few seconds to do so, and then I'll show you what it looks like on here. All right? So now if I go to my list of applications, my first one in here is Angry Birds New Jersey. And when I think Angry Birds New Jersey, this is kind of what I think of. So that's what our Angry Birds application does at this point. But now watch the next time I put this that Maps tag to the back of my phone. Now I have a pop-up asking me to choose which application I want to handle this intent message. Any ideas which one is the real Google Maps? Top one. Top one actually takes us to Bing instead. So this was our Angry Birds application that we just installed. The icon that I show for that pop-up message, the name that I have for my application in that pop-up message, I can control all of that in my intent filter. Don't need any special permissions. It's up to me to get how crafty I want with that tag at that point. So that was kind of fun and interesting. And then with ice cream sandwich, let's see if we can get that down for ice cream sandwich, there's actually a little bit of a fix that's possible for this. That got introduced so that you can actually direct which application you want to handle that intent message. So it's called an Android application record. It's an extra NDEF record that you can add to your tag and say when this URL loads, I want it to also be handled by this particular application that's specified by the package name. So that seemed like a good countermeasure for this type of attack. And then Max started thinking about it and came up with a different idea.
Yeah, so we promised fun with parking meters. Maybe some of you have left the hotel, maybe some of you haven't. But if you walk around, you can see these parking meters. And the way they're supposed to work is you have a mobile application, and you punch in the parking meter number. You have an account with that mobile application, and then you can pay for your parking space using that application. So we were curious. We looked these guys up online, and it looks like they want to deploy NFC soon. So the way we've seen NFC deployed in parking meters in other cities is just a simple tag on the parking meter, and all the tag does is have a URL to the application, and in the get parameter, it has the parking space number. So you're not actually doing payment through this tag. All it's doing is saying, I'm here, and then the application has registered an intent filter for that URL. So it'll pop up the parking application. So no payment, but it's saying where you are. So we thought, what if we implement it for these guys? So the Android application record from Google, this is straight off their page. If no application can start with the AAR, go to the Android market to download the application based on the AAR. So all the AAR is like Corey said, an additional NDEF record with the package name, comm dot whatever. So we figured we'd make a tag, set the Android application record to our application, and smack it right on the front of that parking meter. Big green thing, pay for parking with NFC. Cool, right on the front there. So big props to Jason from IG for writing this. And yeah. So here's our tag. We scan it. It brings us straight to the market to download this application. So we'll go ahead. Yeah, that looks safe. Download Pork Mobile. All it's asking for is network communication. Cool. Accept and download. Accept and download. All right, so that's it. We don't have to open it, but the next time we scan this tag, which is on the front of the parking meter to pay for parking, it opens up Pork Mobile. So a lot, like the way we've seen it implemented other places is it's a login page, you log in, but Pork Mobile gets right to the point. So you can see the zone number there, but then you got credit card, expiration date, we could add mother's maiden name, etc. Successful phishing attack. So you notice the zone number matches also. Well, it did. So just to break it down, the tag has an NDEF URL record to porkmobile.com. The AAR, which is just an additional record in that tag, is comm.porkmobile. Then the application, all it is a web view to our server to collect whatever information we want, credit cards, login, etc. So the countermeasures to an attack like this, particularly this one, is that we're putting the app in Google's marketplace. So at any time, they could revoke this app, like if Pork Mobile gets too popular. So these tags, like Corey said, are $1 or $2 right now. So you'll be left with a bunch of dead tags, just pointing to nowhere in the market.
Okay, so some other applications that first handled NFC that we started looking at was the Foursquare application. So this again had a URL that would be encoded into one of these tags. You get to a new location, touch your phone to the poster, the tag that they have next to the door, checks you in over Foursquare at that location. So our office is near Times Square, New York, so we thought it might be fun to have something like this. If anybody comes and visits our office, go and touch their phone to it and let them check in, let their friends know that they're around Times Square, New York. Well, this URL actually has two important fields, parameters that are embedded into it, the venue ID and the venue name. And the application doesn't check that there's any correlation between these two values at first when it comes in over NFC. So we can tell somebody that they're checking in here to Times Square. When they click the big green check-in square button, they actually get checked into maybe the Chippendales down the street.
4 times.
So basically, if you're an application developer, you've got to think of this input coming in from these tags as untrusted user input into your application. It needs to be validated before you take action on it. So Foursquare did fix this in one of their releases. Also, Colin pointed us to one of his slide decks later on where he had found this a little while before us. Somehow we had totally missed it. But it's a great example of needing to validate your data before coming into an application here over NFC. Now, an example of an application kind of doing this correct is from a really popular NFC application on BlackBerry devices. I don't have a whole lot of other demonstrations with the BlackBerry because there's 4 NFC apps in their marketplace, I think, at this time, and one of those is football related. So NFC Launcher, though, it's really interesting. This is an idea that you could take these tags, place one of them on your car dashboard, place another one next to your nightstand at home, and when you go and you just place your phone on there, it'll launch, say, your navigation app when you get into your car. When you put it next to your bedside, it now launches your alarm clock application or something like that. And this does this simply by checking the UID of the tag where you place your phone. There's no data actually written to that tag. All the information about what action to take is actually written in the application space. It records it there on the device. So if you see a new tag, it doesn't do anything malicious to it. If you change the data on a tag where it's placed somewhere, it's not going to take any different action on the phone itself. So that's a nice way of doing these tags and making sure that it's done in a secure way. Another interesting thing, if you start playing around with BlackBerries and NFC, is that for their BlackBerry emulator, they actually have, it can connect out to the NFC control simulator. And this is a really interesting setup where they have a lot of different tag types, the card types, as Max referred to earlier. And you can write whatever sort of data you want to these tags and see what happens when your emulated device goes and reads that. Unfortunately, this will crash randomly and a lot. And it's not really good test harness to use for trying to fuzz these devices. You're definitely going to want to do it with actual hardware. You'll get misleading results with this. Okay, now let's talk a little bit about NFC and privacy. You may be thinking, your mobile phone and privacy information, you have larger concerns about privacy in your device than NFC, between your GPS, your carriers knowing things about you, carrier IQ getting installed. There's bigger fish to fry, but it's interesting to think about using NFC to actually locate you versus things like GPS, where maybe you can get a couple meters around you, or maybe it doesn't work so well indoors, but NFC, if I'm reading this tag, I need to be within a very near range to be able to read this tag at this point. So it puts me at a very specific location. If I'm collecting the UIDs of these tags, that means I read a very specific tag. So if I know this tag is a Google Places tag at this restaurant, and somebody's able to see that I scanned this UID at a certain time, they can put me at that location. This may also contain information about point of sales transactions and that being stored on your device. People can tell when you made a transaction and where potentially. If I use the beam technology to beam something from device to device, if it collects any sort of information about the device I sent it to, that I paired with a certain Bluetooth connector or the MAC address from a Wi-Fi access point, again, puts me at a certain location. So in terms of information that's generated on your device when you read a tag, if you're looking at Logcat, looking at the logs of your Android device, you will see an intent message typically get generated. You might see some other information as well, depending on the type of the NFC interaction. But these logs are transient. If you restart your phone, you lose those logs, fill up the log data, they'll start scrolling off. So that data is not stored or kept. But if we looked at some of the popular applications, such as the tags application, and seen if they actually store any records in their own application space, turns out that the tags application for Google does actually keep a SQLite's database in there. And in there is a date timestamp down to the microsecond. It's got the NDEF message from the tag that we read. It also has any of the raw data from that tag in the bytes field, but the one thing that it doesn't collect the UID for the tag itself. So I can't, even if I can say I read a places tag, I can't say it was this exact places tag that's put at this location. It could have been one that Max, forwarded on to another card. Now, if you're writing data to these tags, one of the things to watch out for is that typically when you do a write command to these, they don't write up the full sectors on the tag. It only writes as much information as what the record, the message is that you're putting to the tag. You saw that earlier with the NDEF message format. There's a bunch of length fields and everything else like that, so it knows how long that message is supposed to be as it starts reading the data and writing it as well. So in this example on the screen here, I had a much longer message originally pushed to this tag, and then when I wrote a shorter message over it, it didn't actually wipe out that other contact information that was previously written to the tag. So if I looked at an application that's going to read each one of those sectors out from the tag, I may see data like this left behind on it. Okay, and then what everybody starts getting interested in is, what about digital wallets and using this for actual payments? What sort of technology, what sort of countermeasures are there for actually stopping other applications from listening for these intent messages that are going to trigger something like the mobile wallet? What if I get malware onto my device? This was a huge year for Android malware. Seeing things like DreamDroid, where it's actually going to root the device through an application that came in from the marketplace on devices that were vulnerable to it. Or what happens if my device, if it gets lost or stolen, somebody actually has it now physically in their hands, are they able to pull out this memory and get my credit card information out of it? These are all concerns that people have. And in order to do any sort of the mobile payment applications that actually use NFC so far, what seems to be regulated and is being required is that they have a secure element actually in the device. So it's like having a computer within your computer with you all the time. So this allows, then makes it, it's kind of, it runs, the secure element runs its own operating system. You're going to have embedded applications that are kept within inside there. There's going to be a simple communication protocol between things in the operating system land, your Android application, talking to applets in the secure element. It's going to be able to enforce strong crypto and access control in here. So even if you root the device, that we've all commonly seen for Android applications or Android devices at this point, it doesn't give you access to the secure element. It just allows you to communicate with it. And your secrets are still going to be safe in there at this point. So the Nexus S, the Galaxy Nexus, they both have this PN65N chip from NXP, and that's the secure element and NFC chip that they're using at this point. Okay, so from application land trying to get to that data, that should be a hard thing for malware to do, for somebody that roots our device and so forth. But what about that idea of the tap attack? You get into a crowded subway, crowded hallway here at Shmoocon. What if somebody has something that's like a point of sales reader, comes up to your pocket, tries to tap your phone now to grab that credit card information out of there? So this is the type of attack that's been around for a while. Paul Holman has a great Boing Boing video where they basically walk through this and he shows it using a full-size point of sales reader. But there's other ways that this could probably be done as well. But it seems like a very valid attack that could happen against now these digital wallets. One of the main countermeasures to keep in mind here, at least with the Google phones, is that, and this is from their website here when they talk about Google Wallet, the NFC antenna in your phone is activated, only activated when the screen is powered on. So you got to make sure that your screen is on before it's even going to be able to read or interact with any of these tags. That was the case for gingerbread with ice cream sandwich. If you have it locked, you now have to have it unlocked and on as well. There is some talk that some of these chips will work in low or no power mode. Remember, at this point, your phone is emulating a tag, and these tags are all unpowered. So theoretically, you could have this getting its power simply from the reader coming to it. You'd be able to actually pull out your battery in some cases and still be able to have your tag being read. So that'd be interesting. It's not the case with any of the Nexus phones at this point, though. On BlackBerry, however, their default NFC settings are set to actually allow for this. So by default, they will allow card emulation when it's locked and when it's powered off. There's not a payment application on BlackBerry yet for us to really test this with, but that's what their settings here for their NFC permissions are on the device. Now remember, this is just to have the device actually emulate a tag for either payments or for getting onto the subway late at night and your phone has died. It's not for actually reading the data off the tags. That still, again, won't work when it's locked or powered off. Okay, so back to the tap attack. Google Wallet, if I actually have Google Wallet on my device, I stick it to the point of sales reader, watch the data coming back out of it. Am I going to be able to get my credit card information? Yes, you can. But for Google Wallet, you actually have to go through a number of steps. You have to make sure your device is on.